Hi, welcome back. Let us start numerical number 11 to 15 of exercise 8C. 11th question. What is the resistance under normal working conditions of an electric lamp rated 240 volt and 60 watt? So R is equal to V square upon P. V is equal to 240. So here we have to square it upon 60 for 960 ohm. That is the resistance of a bulb. Now the question is, if two such lamps are connected in series, explain why each one appears less bright. So to find out that answer, first let us find out that how much current flows through one single bulb when it is connected to 240 volt mains. So to find out the current, we can use the formula P upon V. Power is 60, voltage is 240, 1 by 4, 0.25 ampere current flows through a single bulb when only one bulb is connected to 240 volt mains. But now if two bulbs are connected in series, if two bulbs are connected in series with mains, then the current of the circuit will definitely reduce. So to find the new current now in the circuit, let us first figure out what is RS, that is 960 plus 960, which is 1920 ohm. Okay, voltage of the mains is 240 volt. So now we can find out I using V upon R. V is equal to 240, resistance 1920, which is 1 by 8, 0.125 ampere. So you see that now current flowing through each bulb is only 0.125 ampere, which is half of the previous case. Okay, when only one bulb is connected to the appliance to the supply. So now new current is 0.125 ampere. Current is less, and that's why each bulb glows with less brightness. 12th, two bulbs are rated 60 watt, 220 volt and 60 watt and 110 volt respectively. Calculate the ratio of their resistances. We know that resistance is equal to V square upon P. So R1 upon R2 is equal to V1 square upon P1 upon V2 square upon P2. This becomes R1 upon R2 is equal to V1 square upon P1 into V2 square upon P2, that P2 will go in numerator. V1 is 220, so 220 into 220 into P2, second power of the second bulb is 60 watt upon P1, power of the first bulb is also 60 into V2 is 110, so 110 into 110, 60 and 60 gets cancelled, 110 times 2 is 220, so the ratio is 4:1. 13. An electric bulb is rated 250 watt, 230 volt. Calculate the energy consumed in 1 hour. Energy consumed in 1 hour. E is equal to power into time. Power is 250, time is 1 hour, unit is watt into hour. Let us convert watt into kilowatt. For that, simply we need to divide 250 by 1000 into 1. This is 0.25 kilowatt hour. Second is the time in which the bulb will consume 1 kilowatt hour energy. Time we want to find out. So T is equal to energy upon power, the time in which the bulb will consume 1 kilowatt hour energy. So energy is 1 kilowatt hour and power of the bulb is 250 watt. So let us convert kilowatt into watt in numerator, that is 1000 watt, 1000 watt into hour upon 250 watt. Watt gets cancelled, 250 times 4, 1000. So here answer is 4 hours. 14th, 3 heaters each rated 250 watt 100 volt are connected in parallel to 100-volt supply. Calculate the total current taken from the supply. Now, since heaters are connected in parallel with each other, first we can find out equivalent resistance Rp using the formula R1 by 3. What is R1? R1 is equal to V square upon P. Voltage is 100, so 100 into 100 upon power is 250. 5 5s are 25 and 5 2s are 10. 5 in 20s are 100. So this becomes 40 ohm. Okay, R1 is 40 ohm. So Rp is now 40 upon 3 ohm. And then we can use the formula V is equal to IR to find the total current of the circuit. Voltage is 100 is equal to current we want to find out, and Re is 40 upon 3. So current is equal to 100 into 3 upon 40, that is 30 upon 4, that is 30 into 25 upon 100. 7.5 ampere is the current of the coming out of the battery. 7.5 ampere. Then the resistance of each heater that we already calculated, 40 ohm, and the energy supplied in kilowatt hour to 3 heaters in 5 hours. Energy supplied in 5 hours. So energy is equal to power into time. Okay. Energy supplied in kilowatt hour to the 3 heaters in 5 hours. So here P will have to be the total power, that is P1 plus P2 plus P3 into time. P1 is 250 watt, so 250 plus 250 plus 250 into time is 5 hours, 750 into 5, but this is watt hour. Okay, this answer is in watt hour. So to convert watt into kilowatt, let's divide this value by 1000. So this is kilowatt hour. This will be 3 and this is 4. 25 threes are 750, 25 fours are 1000, and this is 15 divided by 4, which is 3.75 kilowatt hour. So the energy, total energy is 3.75 kilowatt hour. 15th, a bulb is connected to a battery of PD 4 volt and internal resistance 2.5 ohm. A steady current of 0.5 ampere flows through the circuit. Calculate the total energy supplied by the battery in 10 minutes. Energy supplied in 10 minutes. E is equal to power into time. But power is not given here directly. So we can use the formula P is equal to VI into time. Voltage is known 4 volt. Current is also known 0.5, or let me write half, into time is 10 minutes. Let us convert this time 10 minutes into seconds. So 10 into 60. This is 2 and this becomes 20 into 60, 1200 joule. So energy is 1200 joule. Second is resistance of the bulb. Now to find out the resistance of the bulb, we will have to use this formula. E is equal to I into R plus small r. EMF of the battery is 4 volt. Current is 0.5 into capital R, that is what we want to find out, and internal resistance is 2.5. So this will be 8 is equal to R plus 2.5, and hence R is equal to 8 minus 2.5 is equal to 5.5 ohm. And the third is the energy dissipated in the bulb in 10 minutes. Energy dissipated meaning energy lost, and that is always in terms of heat energy. So H is equal to I square R into T. Current is 0.5 ampere. So 0.5 into 0.5 into resistance of the bulb is 5.5 and time is 10 minutes, 10 into 60. Alright, so on simplifying this we get 825 joules.
Thank you for watching. Please check the link in the description below for more numerical videos. Please like, share and subscribe to my channel.